We could have a quadratic expression, which we could play with, or we could have a quadratic function, which we could sketch, or we could have a quadratic equation, which we could solve, or we could have a quadratic inequality that we could solve. When you're mucking about with a quadratic expression, you've got some key techniques. You've got complete the square, and that gets it into the form ax plus b squared plus c. Its original form is probably going to be ax squared plus bx plus c, all expanded out, or you can factorise and get it in the form something probably like some numbers and an x and some other numbers and an x and a number there and a number there, I don't know, a, b, and then maybe a number at the front, that sort of shape. To sketch the function, you're best off thinking of the quadratic in its completed square form, because that allows you to see how far left and right and how far up and down the parent function has gone. And we all know what the parent function y equals x squared looks like. So for example, let's say we had the function f of x, or y, is 2x squared minus 7x minus 4. Now, if I write that in completed square form, it's going to look like this. I'm not doing this in my head, I've done it on a bit of paper, in case you think I'm a super genius. I am a super genius, obviously, but I'm not currently being a super genius, I'm cheating. So, there it is in its completed square form. Actually, I can write it in its factorised form as well, because I also have that on a piece of paper. X minus 4, 2x plus 1. Now, the one I want for sketching is the blue one. But first, I'm just going to have a little look at the y-intercept. So the y-intercept is minus 4, that's negative, and that's what happens when x is 0, nice and easy. Now I'm going to use the blue one to see that it's gone left 7 over 4, and then down 81 over 8. And that's why that completed square form is so good. So here's the turning point, which is what we get from the completed square. Left B, up C, unless B or C are negative, or and then it's the opposite. So that's pretty much it, isn't it? I can now sketch the graph. Goes down like this, turns, and goes up like that. The other key points on the quadratic graph, other than the y-intercept and the turning point, are the roots. And in an ideal world, I'd have factorised and got the roots from the factorised version, because it's so easy. It just gives us x is 4, x is minus a half, done. It's like no work. Minus half and 4, and that's all the information that we could need, really. If I couldn't factorise it, given that I've already completed the square, I would probably rearrange the completed square. So to solve the equation and find the roots, I could rearrange the completed square, or I could use the factorised version, or, which is the same as really, because as using the completed square, I could use the quadratic formula. But why would I do that when I've already completed the square to get the turning point? And also, the quadratic formula is the completed square, as we will see this week when we do the problem sheet. Now, as you all know, to solve an inequality, you use a graph. So we've already got the graph, hooray. So we would look at the graph, work out the roots, we already did, hooray. And then we would just, maybe if I come down bottom right, have a look where that graph is positive and negative. So it is positive all the way along here, then it goes negative, and then it goes positive again. So it depends what the person wants. What did they say they wanted? If they want, for example, they only like looking up. They want to look up. Look up. So that is saying that the quadratic needs to be greater than 0. So for this particular example, they would be happy to the left of that. Maybe I'll use yellow for this. They would be happy here to the left because the graph is positive. Then, oh no, not happy there because at the actual root, they're not looking up, it's 0. Then sad, 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 sad. Then not happy again, but then happy. They're happy when it's positive. So this is the bits that they want. And then we could write that in set notation or in interval notation. So, in summary, things to look out for with a quadratic, to be careful of, is look at the coefficient of x squared. The coefficient means the number in front of. that's wrong, coefficient of x squared. If it's positive, then that's a positive quadratic, and if it's negative, it's a negative quadratic. So that's something that students sometimes miss. And when you're sketching, use the completed square form. That's your best one. The completed square for sketching. It shows you where that vertex is, where it's gone, and you can just track that vertex and then sketch it. And then don't forget to work out the roots. So that's solving the equation. Y is 0, and the y-intercept is easy. Just put in x is 0, and you're done. And there you have it, all of quadratics in 6 minutes. Make sure your notes look a bit better than mine, and bear in mind all maths, but particularly quadratics, have you got an expression, have you got a function, have you got an equation, or have you got an inequality?